Hi there, everybody. This is Bill MacDonald, the Common Sense Math Doctor. Today we're going to talk about dot plots, difference, and how to use my place value chart to find and compare numbers with a least, a greatest, and a box in the middle to go from least to greatest to the thousandths place in fifth grade. So let's get right to it so that you can get back to whatever you were doing before I interrupted your life. So this question is student expectation 5.9C, reporting category 4, readiness, which means the first time they're exposed to it in Texas at least is fifth grade. Dot plots, where you plot dots on a number line, and then you have to answer questions based on pertinent information that they want to know about. But if your kids don't know vocabulary, such as difference or fewer than or something more than, they're going to struggle, as they did with this question. Only 47% of the kids in fifth grade got a question like this because they have to understand vocabulary. So we got the dot plot idea, the number of quarters for each game at an arcade inside the mall. Okay. So basically for 0, 1, and 2, there are no games that require 0 or 1 or 2 quarters. Because of inflation, there are none that require 11, but all of these games have at least 1 or more. So let's look at the question. What is the difference? Difference, you subtract between the number of games, so opening bracket, that need fewer than 7 quarters. Wall, because of the word and is the comparison. So fewer than 7. So I'll draw a line right before 7 and then draw an arrow to the left. So all those are the number of games that need fewer than 7 quarters. Less than 7 is 6, 5, 4, 3, 2, 1, 0. 1, 2, 3, 4, 5, 6, 7, 8 games require less than 7 quarters. And the number of games that need 7 or more. So since I've already got 7 on the opposite side, I don't need to draw another vertical line. I can just draw to the right, and then I can count how many are 7 or more. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the difference, you subtract of 8 and 13 is 5 games, letter D. So apparently the students in Texas either don't understand dot plots, don't understand what the word difference means because it was with some totally unrelated situations, had a number line just like this, it had numbers, it had dots, and it had to compare the numbers. So you see either you can tell your students it's subtract 8 from 13 or 13 take away 8, the number that needs more subtracted by the number that needs less than 7, and you get 5 games, which is letter D. Okay. Sometimes you can extend the problem by asking questions that would have the other answers. Have your kids come up with their own questions that would have an 8 for an answer, a 13 or a 1. So let's check the other one since we're on a so-called easier problem. This one is 5.2b. It came from question 17. And it was basically looking at place value, whole numbers, and decimals up to the not tenths, not hundreds, but to the thousandths place, where it said when you're looking at numbers from least to greatest. And so I don't know if the one that was on the test was from greatest to least, but I suggest that you when as soon as the kids see the first number and they see least to greatest, they say, okay, this number has to be less than the number in the box, and the number in the box has to be less than the number outside the box in order to follow the rule of least to greatest. So there are the four answers: F, G, H, and J, 7 and 32 thousandths, 7 and 143 thousandths, 7 and 1/10, 7 and 10 hundredths, 7 and 100 thousandths. All of those are true because of the imaginary zeros that come after the one. And then we have 7 and 103 thousandths. But placing them on a number line is hard for some kids. So if for those of you that have purchased any of the Common Sense math practice tests, you get a digital copy of this where we can say, okay, there's our number, 7 and 35, the number that you say, and then its address thousandths compared to F, G, H, J, and our other number that was 7 and 102. You say the number and then you say its address where the last number is thousandths. So what has to happen is, in order for each letter to be true, it has to be larger than the number above it, but less than the number below it. So if we look at 7 and letter F, 7 and 32 thousandths, it's already not true because the 2 in the thousandths place is smaller than, so it makes the number go down. So I would eliminate F. G has 7 and 143 thousandths. So yes, it's bigger than 0 in the tenths. Yes, 4 is larger than 3 in the hundredths. And yes, no, 3 in the thousands is not bigger than 5, but it doesn't matter because we have 35 thousandths compared to 30, I'm sorry, 143 is what I'm looking at, my bad. 43 hundredths is larger than, sorry, 43 thousandths, when we already know that this one is, the tenth is larger, this one is larger. But even though the 3 is smaller in the thousandths place, because we have 35 thousandths in our original number, as long as the two numbers together, 43 thousandths is larger. So that part is true, but what part is not true is that 43 thousandths has to be also smaller than the one with 102 thousandths and 143 thousandths is larger than 102 thousandths. So we're going to eliminate letter G. Our H says 7 and 1/10, which is also 7 and 10 hundredths, 7 and 100 thousandths. Is it larger than, is 35 thousandths smaller than 100 thousandths? Yes. So the top part is true. It's larger than the number above it. And the bottom number has to be true as well. That 7 and 100 thousandths is smaller than 7 and 102 thousandths. Since both sides are true, letter H is true. So that just means we have to find out why letter J is false. 7 and 103 thousandths is already wrong because I have it right next to my other number. It is larger than 102 thousandths. So even though the top part was true, that 7 and 103 thousandths is larger than 7 35 thousandths, the top part and the bottom part have to be true, but this letter has to be smaller than the one outside the box. So the only one that is true on both sides would be letter H. And so this is called my common sense mathematic chart. So as you see there, it's got my email address. So if you would like the 5th, 4th, 3rd, 6th, 7th grade practice math test from any of those grades from any of the last 3 to 5 years, I pretty much put all of them as practice tests, looking at the 10 to 20 most difficult questions. And so those came from questions 15 and 17. And as you can see, they did pretty poorly. So I would recommend that you practice them. And so if you don't have my mathematics chart, then grid paper can work just fine. You just need something that represents whole numbers, and for 5th grade decimals, not just to the hundredths place or to the dimes and pennies for 3rd grade, but to the hundredths place and the thousandths place for 5th grade. So apparently the kids didn't practice going that far and checking that the box number was larger than the number outside the box and smaller than the one on the other side of the box. So that's my strategy. That's a way to teach it. Hopefully you will share this math video with your teacher friends who are working on dot plot and place value, least to greatest or greatest to least. You could flip those numbers around and do the same thing, greatest to least, and it will you'll get the same answer because there's only one number that falls between those two outside numbers. Thank you guys and have a wonderful rest of your week.